Assalamualaikum and good morning to all my friends and lecturer. Today we are from Group F. The event scope we choose is a tennis court, UMK Julius Campus for this assignment mathematics subject. So let me introduce my group members. So I'm the group member number 1 from my group.
And I am number 2. And I'm number 3.
So without wasting our time,
Let's get started.
Pengawan Solo dengan irama alunan on kita Pak Mloyo pula jalannya keloyoran
Hi, my name is Muhammad Arif Putra bin Muhammad Farid. My matrix number F220147. So, the question I get for my question is shutter bat by the tennis player.
Okay, hi, Assalamualaikum everyone, and very good morning. I am a member number 2. My name is Ku Muhammad Arif bin Kukasim. My metric number is F22A0011. Okay, for my part, my question is what is the rate of the ball is falling down on the court?
Hi everyone, my name is Wong Wai Chong and my matrix number is F22B0059. So my topic for my mathematics assignment is what is the maximum intensity of the ball and what time does it occur?
The problem I get for a question 1 is shutter pad by the tennis player. This question is, a player stand at a point A on one side of a rectangular court, which is 30 meter long and 10 meter wide. The player wants to reach point B on the opposite side of the court as quickly as possible. However, the player can only move along the edge of the court. What path should the player take to minimize the distance traveled? So, the solution, X and Y, represented by the player position. X a distance along the length of the court, and Y width of the court. So, distance between the player position, point B, can be calculated by using the distance formula at the right here. So, solving this equation gives us X equal to 30 and Y equal to 10, which means that the player should travel directly from point A to point B in a straight line. So, the solution for this question is the distance equal by square root, open bracket, x minus 30, close bracket, power of 2 plus, open bracket, y minus 10, close bracket, power of 2. So, acceleration distance slash acceleration x equal by 2, open bracket, x minus 30, close bracket, equal by 0. Acceleration d slash acceleration y equal by 2, open bracket, y minus 10, close bracket, equal by 0. So, let me pass the next question for members number 2.
Hi, for my part, the problem title is the rate of the ball is falling. The problem is a tennis ball is hit directly upwards from a height of 1.5 meters above the tennis court. The height of the ball above the court at time t is given by the function ht equal to negative 4.9 t squared plus 10t plus 1.5, where ht is measured in meters and t is measured in seconds. Find the derivative of ht with respect to t and determine the rate of which the ball is rising or falling after 2 seconds. So, the problem is we can solve with the derivative application. ht equal to negative 4.9 t squared plus 10t plus 1.5. So we can differentiate this function, so the derivative of ht equals to negative 9.8t plus 10. So when the question said the rate at which the ball is rising or falling after 2 seconds, so when t is equal to 2 seconds, we can substitute this value into the function. So the derivative is h in bracket 2 equal to negative 9.8 times with 2 plus 10 and equal to negative 9.6. We can conclude that the negative sign indicates that the ball is falling. The magnitude of the rate is 9.6 meter per second. Thus, after 2 seconds, the ball is falling at the rate of 9.6 meter per second. So that's all from me.
During last semester, my club activity is actually tennis. What a coincidence. So, I've been wondering, what is the maximum intensity of a tennis ball when we hit it with a tennis racket? And what time does it occur? So, here is the function for the intensity of tennis ball. I in brackets t equals to 10t minus t squared, where I represents intensity and t represents time in seconds after the ball is struck. So first, in order to find t, we take the derivative of I in brackets t respect to t, which form our first derivative. After that, to find the critical point, we set I in brackets t equal to 0 and try to solve for t. Therefore, we found the critical point, which occur at 2.5 seconds. But we are not done yet. To know whether it is maximum or minimum, we can take the second derivative, which ended up giving us negative 2. So, since the second derivative is negative 2, and we found out the tennis ball reaches its maximum intensity at time of 2.5 seconds, we can now substitute 2.5 seconds into the original function. So that is how we get 18.75 watts as the maximum intensity of the tennis ball. Hence, the maximum intensity reached by tennis ball is at 18.75 watts and it occurs at 2.5 seconds. So that is my question and solution. Next, I would like to pass my turn to the fourth member of our group.
Hi, my name is Nur Asmisa. I as a member 4. My problem title is maximum height of the tennis ball, where a player hit a tennis ball from the other side to this side. And I will find curve of tennis ball. Is defined by the function ht equals negative 5 power of 2 plus 6 and plus 2 meter. So here I use that formula to finding x coordinate, and the vertex is given by x equals negative b bar 2a, where a and b are the coefficients of quadratic equation. So in this case, a equals negative 5 and b equals 6. So x equals negative 6 bar in bracket 2 in bracket negative 5. Then x equals negative 6 bar in bracket negative 10. So x equals 0.6. So the ball reached its maximum height at time equals time equal 0.6 second. Then I start to find corresponding head. I substitute this t value into the function. So h 0.6 equals -5 in bracket 0.6 power 2 plus 6 in bracket 0.6 plus 2. So h 0.6 equals -5 in bracket 0.36 plus 3.6 plus 2. So the answer I got is h 0.6 equals -1.8 plus 3.6 plus 2. Then h 0.6 equal 3.8. So the answer is 3.8 meter. So this answer is a maximum height that reached by the tennis ball. Thank you.
Jack is UMK Jelis Campus Tennis Court. Betul lah.
Okay,
Assalamualaikum and hi. Good morning. Bodoh sih. Dah jadi macam. So, without wasting any time, let's get started. Our time.
Okay.
Our time.
Without wasting our time, let's get started.
Without any.
So, without wasting our time.
So without wasting our time. Okay. So without waiting.
Cepat panas gila.
Okay. So without wasting our time,